So now that we've discussed polynomials, we can now look at solving a polynomial inequality. To solve a polynomial inequality, we first solve the corresponding equation. Then we draw a number line. Then we mark any solutions from step number 1 on that number line. Those marks will create intervals, and we're going to choose a test value for each interval. We're going to substitute that test value into the original inequality to see if it makes that original inequality true or false. If it's true, then we have a solution. If it's false, we do not. So, any true values are representative of that entire interval, and therefore we would shade that interval, and those shaded intervals will correspond to the solution of the inequality. So here we go. Let's go ahead and solve the corresponding equation of this polynomial inequality. So we're going to look at x plus 5 quantity squared times x minus 1 equals 0. So we get x equals negative 5 or positive 1. Let's draw a number line. So negative 5 and positive 1 can go on that number line. Now we see 3 intervals, and we can choose a test value on each interval. Any number on the interval will suffice. So we could choose negative 7, we could choose negative 1 million, or negative 6. Between negative 5 and 1, we can choose any value. I suggest always going with something that's easy, so 0, if we can choose it, is always a good choice. And then to the right of 1, we can choose 2. And we're going to substitute these values into the original inequality. So if we substitute negative 6 in, we would get negative 6 plus 5 is negative 1, square it, and that will be positive 1. And then negative 6 minus 1 is negative 7, so we get negative 7. And so negative 7 is greater than 0. Is that true or false? That's false. If we substitute 0 in, we get 25 times negative 1. So that's negative 25 is bigger than 0. That is false. If we substitute 2 in, we get 2 plus 5 is 7 squared, would be 49 times 1 is 49. 49 is greater than 0. That's true. So we will shade to the right of 1 because that is our true interval. And the question is now, do we include 1? Well, 1 makes our equation true. So it would make this quantity equal to 0. We don't want equal. So we will not include the 1. So our answer will only be 1 to infinity. So now let's solve this inequality. We'll start by looking x to the 4th equals 81x squared. To solve this, we need one side equal to 0. Factor out an x squared, and we will get x squared times the quantity x squared minus 81. So x squared times x plus 9 times x minus 9 equals 0. So our solutions correspond to the factors. So x equals 0, negative 9, positive 9. Now let's draw a number line. We will put those solutions to the equation on our number line in order. So negative 9, 0, 9. Let's check intervals. So we can choose negative 10, negative 1, 1, and 10. And we'll substitute those into the original inequality. So if we substitute negative 10 in, we obtain 10,000 is less than or equal to 8,100. That's false. If we substitute negative 1 in, we get 1 is less than or equal to 81. That's true. If we substitute 1 in, we get the same thing, so we get true. And if we substitute 10 in, we get the same thing as whenever we substituted negative 10 in. So let's shade the true intervals. So now the question is, what do we do with endpoints? So negative 9 makes this true because it allows for equality. So negative 9 gets included. 9 would get included for the same reason, as would 0. So if we look between negative 9 and 9, everything gets included, even the 0. So our solution is negative 9 to 9.